Hello everybody, this is Ice, and welcome back to episode 1 of Let's Program, a new weekly show that I will be uploading to the Ice and MC channel, in which we create awesome programs and software for my Redstone computer, the Ice 100. Now, if you haven't seen the video about the Ice 100, you can click on the annotation on the screen just about now. There's a download there and all that good stuff. And yeah, that's pretty much the goal of the series. We're going to be creating some awesome stuff based on viewer feedback. And there we go. There's the first part. Just a little bit of information about this series. First of all, it will always be uploaded to my channel at 4 o'clock Eastern Standard Time on Wednesdays. Every Wednesday. Don't expect me to miss any episodes this time. I'm going to really concentrate on making this a regular show. Depending on the feedback, I might decide to upload less or even more, depending on how people like the series. Now, second, all you'll need to follow along is the latest copy of the Ice 100 CPU download. Now, currently you can get that at the Minecraft forum thread, at the YouTube video I recently put in an annotation, and it will also be in the description of every video. And that's pretty much where you can find it. It will always tell you if I find a bug, and I will update the download and make it available for you again. That's pretty much that. And without further ado, let's get started with the video. Now, before we can start creating awesome programs and video games and all that cool stuff, we need to kind of learn how to use the computer, because you have to use something before you can program it. I mean, that's just common sense. So that's going to be the focus of this first episode. The second episode is going to be kind of showing you how the whole computer itself works and some basic goals of the instruction set down there. But for now, we're going to be focusing on what's up here, all of the different controls and commands in the computer. And the first thing we're going to do is actually run the addition program that comes with the computer. Now, another thing that would be helpful for you to follow along with this series is for you to know binary. There are some great tutorials out there on binary. I'm going to link one in the description by Proper English 19. It's really not that complicated, but I'm going to assume you know it for this entire series. With that said, let's get started. So, we walk into our computer's control room and we see all these lights and levers and switches. What do we do? Well, when you come in, this lever will automatically be enabled. Keep it on. This enables the program and it won't really do anything if this lever is not on. So keep it on at all times unless I tell you really not to. Now, over here, we have the on and off switches of the computer. These are important if you hadn't noticed. So, to get started, we're just going to turn the computer on. Let's do that right now by hitting the on button. Now, as you can see, the light will turn off on the off and turn on the on, which signifies that we have turned on the computer. And it's now processing stuff. Now, we've already come to the first little part of our user system, because since we're adding two numbers, what two numbers are those going to be? Well, this is the user input that it adds. Here we have a little light on over our submit button, and basically what we can do here is input a number in binary. So let's add 12 plus 7. So first we're going to put in 12, which in binary is 8 and 4, and then we're simply going to hit submit, and that's going to send our data into the computer. The light will turn off, and now it will start processing. This can cause some lag, but then, soon later, it will ask for our second number. As you can see, this light will light up again. So we're going to enter 7, because that's our problem. We're doing 12 plus 7, and wait for that to go in and hit submit again. And now we wait, and just kind of stare up at the screen. And with that, once this comes out, you have pretty much operated a program. It's not a very complex one, but we'll talk about the other features a bit later. Let's just wait for this to give us an answer. I can feel it coming just about now, depending on the lag. And as you can see, it has successfully added 12 plus 7 and given us 19. Now this program also automatically turns off the computer, which is really nice. And yeah, you've now run a program, it wasn't too hard, and you've added two numbers with the Redstone computer. Congratulations. Okay, so you've added two numbers. You're probably pretty proud of yourself. You've learned how to use the user input effectively, and input a number in binary and submit it to the computer. But there's still a lot of random stuff around here that you don't understand. The only other thing you really do understand right now is the on-off switch and the display output. So I'm going to attempt to explain all of the different parts, including this and this. So let's get on with that. First of all, this. This is a binary output panel. Nothing too special. You can just display a number in binary. Similar to that, except it's not as fancy. Second, over here we have some general indicator lights. Now, these don't really mean anything right now. They could mean anything. Depending on what program you're doing, this could mean that it's finished processing, could mean whatever the programmer really wants it to mean. It's not like a certain thing that each one means. You can toggle them from the program based on anything you want. Over here, we have the general input switches, and these can just be used to kind of get a different type of input from the user. Instead of using a number, they just kind of have true or false. And there's 4 of them, and again, the programmer can access these anywhere in their code. So that's a lot of the stuff done. The information board is pretty self-explanatory, just a few signs. These are the controls and the debug commands. Now, we're not going to be talking about these today, because they're more on the programmer side of things, and they're a bit more complicated to use. So we'll be talking about those in the next episode, but for now, we're going to look at the 2 most interesting parts of the computer, in my opinion. First of all, my personal favorite, the screen, the glorious screen. Everybody loves the screen. This is a 16 by 16 pixel display that programmers can access very easily and basically put stuff on. This can draw squares, it can draw lines, it can draw horizontal lines, and it can just draw regular pixels. When a pixel is drawn, it looks something like this. If we quickly grab this, that's what a pixel looks like when it is on. Very easy to see. Another recommendation when using this computer is to turn smooth lighting on. To minimum is the best option so that it won't cause you lag. But if we turn our smooth lighting off for a moment here, sorry about the graphics rendering there, but if we turn our smooth lighting off and activate a pixel, just do that. As you can see, it's very hard to see and very faint. The 7-second display also looks absolutely terrible. But if we turn on smooth lighting, suddenly it just looks clear, crisp, and generally nice. So that's a little suggestion of mine. Very simple, just a screen with fills. Now over here we have the last part of the computer that a user would ever have to worry about. This is what I like to call ROM, or read-only memory. And as you can see, it's just a little portion of the computer that goes into it. And basically, this is just a bunch of user inputs, just like the one over there, except you don't have a submit button. There's 8 of them, so you can just have numbers, and the computer can read any of these numbers at any time. Now, in binary, the lowest bit, or least significant bit, is at the bottom, and the bits will slowly get higher as you go up. If I ever release another update to the ICE 100, I'll probably put signs here displaying the values of the bits, but that's not too important. If you're using ROM, then you probably know how this works. And I'm going to quickly change my addition program to demonstrate how ROM works. Just one second. I didn't really demonstrate that because I didn't think it was necessary, but our addition program is now all new. Instead of asking for user input, it will now ask for 2 values from ROM, these first 2 ones here. So, let's say we wanted to add, well, 12 plus 7, since that's our special problem. So, we'd put in 12 on one, and 7 on another, and this program is as easy to operate as they come. If you can't operate this one, maybe you shouldn't be watching this series. All you have to do is go on here and press the on switch. And now we're going to wait. It does take a while for this program to work because it's not optimized for ROM, it's optimized for user input, but we'll worry about that later and talk about all that stuff. But for now, let's just wait for this to happen. It will take quite a while, and it would be nice if I had something to talk about as well. But even now, as you can see, it is turned off. The answer is not changed because, well, it's still 19. We're still adding 12 plus 7. And there we go. That's pretty much every piece of the computer that matters. This episode was pretty short because I didn't have any programs to show you. I didn't have any complicated instruction set to explain to you. And that's pretty much that. It's a very simple to use computer, really. That's one of the main things I designed it for. To be not, oh, there's a bunch of random switches here that I have no idea how they work. No, everything's fairly simple. If you don't understand it, you will understand it by the end of the series. And yeah, there's really not much else to it. I'm just going to leave now because there's really nothing else for me to do here. If you enjoyed the video, please leave a like, and maybe even subscribe if that's your thing. And never miss an episode every Wednesday at 4 o'clock p.m. EST. And there you go. Hope you enjoyed, and as always, bye now.